All right, grade nines. This is our one of the first lessons in chemistry, I guess not quite the first. And we're going to talk about classifying matter as pure substances or mixtures. We've got the three states of matter, all kinds of examples of different things: hats, pencils, milk, juice. Those are liquids, wind, air, steam, fog. Most of that's made of just air or water. But we're doing more than just classifying things as solids, liquids, and gases here. We're going to take all matter and classify it. So you'll need to pause this as you go along to take this note. It's only a few slides long, but this concept map to start with is probably the most important slide in the whole thing. So classifying matter. So everything can be classified as a pure substance or a mixture. For example, vegetable soup is most definitely a mixture. You can see with your eyes the different things that are in that mixture, whereas pure water, not as clear whether or not that's a pure substance. You can't see anything else in there. So in a pure substance, all particles are exactly the same. All particles are the same, and in a mixture, all particles are not the same. A pure substance can be categorized as one of two things. Either it's an element like carbon, nitrogen, or oxygen, just one type of atom, that's what an element would be, or a compound where two or more elements are put together in fixed proportions, like I'm sure you guys recognize H2O as being water, and you may or may not recognize NaCl as being salt. So that's salt, and that's water, and they are compounds. So if we had a powerful enough microscope to look into a thing of pure water, then every single particle would have one oxygen and two hydrogens on it. Of course, there would be billions and billions and billions of these particles, but every single one of them would have one oxygen and two hydrogen on it. And therefore, each particle in the water is the same. Same with the salt. If you have a chunk of salt, say in solid form, then every part of that salt is going to have one sodium and one chlorine atom bonded together in some sort of in a solid crystal structure. So then we're on to mixtures. So mixtures again can be categorized as two different things: solutions and heterogeneous mixtures, also known as, I'm just going to write AKA, mechanical mixtures. I'm just going to write mechanical because that's all the space that I have there. So let's start with a solution. In a solution, you can only see one thing, like tea, like Coca, like pop, anything that only has one phase. One visible component means it has one phase. That's just a science nerdy word of saying that you can only see one thing. Well, take, for example, if you were to dissolve some sugar or salt in water, you can't see the salt, you can't see the sugar, but you know that's not a pure substance, that's a mixture. It's salt water, it's sugar water. So I'm going to write another word here that you guys should add: dissolved. Just a key term there, that in a solution, you can only see one thing because you've got two things together, but one of them's dissolved in the other, like salt water, like sugar water, etc. Even in tea, you've got the particles of tea that dissolve in hot water. A heterogeneous mixture or mechanical mixture means you can see more than one thing. Like if you have water and oil together and you let it sit, you'll see the oil sit on top of the water. Pizza is definitely, you can see cheese, sauce, crust, different things. That's definitely a mixture. Most types of soup are probably heterogeneous or mechanical mixtures. All right, so that's how you identify these things. Let's move on and see if we can practice it a bit. Well, we'll further define each thing. So a compound is a pure substance that contains two or more different elements in a fixed proportion. Fixed proportion means like that whole H2O, there always being two H's with one O. You know, HO or HO2, that is not water. That is not water. only H2O is water. So that's what it means by a fixed proportion, always 2 to 1. Compounds are formed when elements combine together in chemical reactions. Good place to pause the video here, get down what you need to get, and then continue on. Compounds may be broken down into elements by chemical means, meaning we can use chemical reactions to break down these things into elements. For example, this is again H2O. You can run a high voltage or high current electricity through water, and you can break it up into hydrogen gas and oxygen gas. And that's something you guys will do in your next science course. When 2 or more elements combine to form a compound, the compound will have a physical and chemical properties completely different from the property of the elements that it's made of. For example, sodium by itself is extremely dangerous. It would be toxic to eat. Chlorine gas is used in World War II or I forget which one it was, and one of them as in chemical warfare because it's extremely toxic to humans as well. So these are both really bad things, but you combine them together and you get just table salt, which is, well, I don't want to say that it's harmless, but it's certainly not going to kill you. And most of the foods we eat have sodium chloride in them or some type of salt. So there's just a little thing, a little extension on compounds. I don't think I need to get into any more detail on the mixtures side of it. So we'll end that that lesson right there. And let's just look at what you have to do with it here for a second. Let's go to Google Classroom. So you've done a very quick, short note on pure substances and mixtures. If you missed any of the slides, go back and get them. And then read section 5.1. You'll have to read the section. And I posted these PDFs of these rather than take pictures out of the book. It's going to be a lot nicer to read on your phones, computers, whatever you guys are reading these sections on. And there's lots of good chemistry information on mixtures and pure substances. And after you've read through that, oh, by the way, you don't have to read through like the try this unless you're thinking of trying it. And the did you knows and stuff like that. It's really just the main information through the center of the document. And then I've made a copy for each student of this Google Doc where I want you to answer the following questions. I think it's 1 to 6 and 8 on page 178. That was a part of the section that I just looked at with you. And you'll have to go through and read that section, of course. And then I've posted the questions right here in this Google Doc, 1, 2, 3, 4, 5, 6, and 8. A lot of which, at least half of this, more than half, I would say, except for the questions about the particle theory, you guys are going to be able to answer them just by paying attention and writing down the note that we just went through. But number 1, list the 5 main ideas of the particle theory. That'll be in that section. All right, so make sure you go through that section and get that. I've made this Google Doc available. I made a copy for each student, so you can type your answers right into that. There's no diagrams or anything required, so it should just all be text, and then you can submit it when you're done, okay? So let's close that off and see if you have to do anything else. No, that is it for this particular block. Read the section. I'll go through the note, make sure you have it all down. Read the section, answer and submit the questions. I'll stay on Google Meet for as long as you guys need help. I'll right up until the end here. All right, guys, that is going to be all for now. Good luck.